What if I told you that humans might not be the first intelligent civilization on Earth? What if millions of years before we built our cities and sent rockets to space, another advanced species rose, flourished, and vanished without a trace? This isn't some ancient alien conspiracy theory. This is a serious scientific question posed by real scientists, and the answer might fundamentally change how we view our place in Earth's history. Today, we read diving into the Silurian Hypothesis, a thought experiment that asks one of the most mind-bending questions in all of science. Could we even detect an industrial civilization that existed millions of years ago? And if we can't, what does that mean for the search for life in the universe? Let's find out. In 2018, two respected scientists, astrophysicist Adam Frank and NASA climatologist Gavin Schmidt, published a paper with a provocative title, Silurian Hypothesis. Named after an alien-reptilian race from Doctor Who, this wasn't about proving ancient aliens existed. Instead, it was a serious thought experiment. If an industrial civilization had existed on Earth millions of years before humans, what traces would they leave behind? And more importantly, could we actually find them? Here's the uncomfortable truth they discovered. After just a few million years, almost all direct evidence of our civilization would be gone. Cities crumble, plastic decomposes. Even our most durable structures would erode away. The geological record would smooth over nearly everything we've built. Think about that for a moment. Everything you see around you, skyscrapers, highways, smartphones, satellites, could theoretically vanish from the geological record in a cosmically short amount of time. So how would we look for something like this? What clues might remain? Let's talk about what an advanced civilization actually leaves behind in the geological record. First, fossils. You might think we'd find fossils of these ancient beings, right? Well, here's a sobering fact. Fossilization is incredibly rare. Of all the billions of humans who have ever lived, we found only a few thousand complete skeletons as fossils. And humans have only been around for about 300,000 years. Now imagine looking for fossils from 100 million years ago. The fossil record is extremely sparse. Entire species that lived for millions of years have left behind just a handful of specimens. If an intelligent species existed for only a few million years, even less than the dinosaurs, they might leave virtually no fossil evidence at all. But there's something more durable than bones: chemistry. An industrial civilization would fundamentally alter the planet's chemistry in specific detectable ways. When we burn fossil fuels, we release carbon that's been locked underground for millions of years. This creates a spike in atmospheric carbon dioxide and leaves a distinct isotopic signature in the geological record. We'd see a layer of sediment with unusual carbon ratios, elevated temperatures, and signs of rapid climate change. Sound familiar? That's because we're creating exactly this signature right now. We've also created entirely new materials that never existed naturally. Plastics break down into microplastics that could persist in sediment layers. Aluminum, which is almost never found in its pure form naturally, is now everywhere. We've created synthetic radioactive isotopes from nuclear tests that will mark our geological layer forever. An ancient civilization would likely leave similar markers: strange chemical compounds, unusual mineral concentrations, or isotopes that shouldn't exist naturally. Here's where it gets really interesting and humbling. Earth is 4.5 billion years old. Complex life has existed for over 500 million years. Humans have been industrial for only about 200 years. That's a tiny, tiny fraction of Earth's history. If another civilization existed for, say, 100,000 years and then vanished 200 million years ago, finding evidence would be like looking for a specific grain of sand on an entire beach. The geological record isn't perfectly continuous. We have gaps, erosion, and subduction zones swallowing ancient crust, wiping the slate clean. Scientists point to the Paleocene-Eocene thermal maximum, or PETM, as a fascinating example. About 56 million years ago, Earth's temperature suddenly spiked by 5 to 8 degrees Celsius. Carbon dioxide levels soared. Ocean chemistry changed dramatically. It looked exactly like what an industrial civilization might cause. The scientific consensus is that this was caused by massive volcanic activity releasing carbon from the Earth's crust. But here's the thought experiment. If it had been caused by an ancient civilization, could we tell the difference? The honest answer is probably not with certainty. So the Silurian hypothesis suggests we should look for specific things: unusual spikes in temperature and CO2 in ice cores and sediment, strange isotope ratios that suggest the burning of fossil fuels, concentrated deposits of refined materials or synthetic compounds, and evidence of extinction events paired with environmental changes. The problem? Many of these signatures could also be caused by natural events like volcanic eruptions, asteroid impacts, or natural climate cycles. You might be wondering, why does this thought experiment matter if we have no evidence of ancient civilizations? Well, the Silurian hypothesis has profound implications for searching for life in the universe. If industrial civilizations can rise and fall on a planet without leaving obvious traces, what does that mean for detecting alien civilizations on exoplanets? We might find planets with biosignatures, oxygen, methane, complex chemistry, but miss that an advanced civilization existed there 100 million years ago. The universe could be filled with the ghosts of dead civilizations, and we'd have no way of knowing. This thought experiment also helps us understand our own impact on Earth. The markers we're leaving: climate change, plastic pollution, radioactive isotopes, mass extinction, will be visible in the geological record for millions of years. We're creating a distinct layer in Earth's history that future geologists, whether human or alien, will easily identify. We are becoming our own Silurian hypothesis. This also ties into the concept of the Great Filter, the idea that there is some barrier that prevents civilizations from becoming spacefaring. If Earth could have hosted multiple intelligent species over its lifetime, and we see no evidence of them reaching the stars, that's a concerning thought. It suggests the filter might be ahead of us, not behind us. So, do scientists actually think there was an ancient advanced civilization on Earth? The overwhelming consensus is almost certainly not. Here's why. Evolution leaves traces. Evolutionary biology gives us a clear picture of how intelligence evolved on Earth. We can trace human evolution back through primates, mammals, and beyond. We have fossil evidence at every major step. There's no gap large enough to hide another intelligent species in our evolutionary tree. And while individual fossilization is rare, we have extensive fossil records of dominant species throughout Earth's history. Dinosaurs ruled for 165 million years, and we have thousands of specimens. If another intelligent species had existed for millions of years, we'd likely have found something by now. We've explored enough of Earth's surface and subsurface that we'd probably have found some concentrated anomaly, like strange mineral deposits or unusual structures that couldn't be explained by natural processes. Adam Frank and Gavin Schmidt were clear. They don't believe an ancient civilization existed. The Silurian Hypothesis is a thought experiment designed to help us think about how to detect ancient industrial activity, whether on Earth or on other planets. It's about asking better questions, not confirming wild theories. So could another advanced civilization have lived on Earth before us? Scientifically, it's extremely unlikely, but not completely impossible. And that's what makes this such a fascinating question. The Silurian Hypothesis teaches us humility. It shows us how quickly geological time can erase even our greatest achievements. It reminds us that the universe is vast, time is deep, and our understanding is limited. More practically, it's helping scientists design better methods to search for life on other worlds and understand our own impact on this planet. We might be the first intelligent species Earth has produced. But in the grand scope of cosmic time, we're also incredibly fragile. Our entire civilization is a thin layer in the geological record, a brief moment in Earth's 4.5 billion year story. What matters is what we do with that moment. Will our layer in the rocks tell a story of a species that transcended its planet, or one that burned too bright and too fast? The universe is still writing that chapter. Thanks for watching. If you found this fascinating, hit that like button and subscribe for more deep dives into science's biggest questions. And let me know in the comments, what would you want future geologists to find from our civilization? See you in the next one.